All right, so we got Ted Doherty with us. Ted, this is the first time you've been a part of one of these, right?
That's right.
So here's the deal: we're supposed to tape these once a week, no matter what,
Yeah.
right?
So you're digging deep, is what you're saying.
Well, we had a plan and a different. No, that's not what I'm saying. But I appreciate you taking the time to jump in here and participate. And we're gonna dig into, like, we've talked about. Oh, why would we do this podcast, and then we talked about AI, of course, and a couple of things like that. But there's one that's been on my mind, and it's I mean, it's pretty fundamental to the industry, which is going to be about P&IDs, piping and instrument diagrams, and you know, we're not going to get into like symbology or something like that. We're gonna talk about maybe why they're important, what we know about them, and kind of their role in the industry and stuff like that. Before we do that, though, you got your favorite shirt on, I see. So a little bit of background on yourself, sir.
Sure. Ted Doherty, mechanical engineer. I went to University of Notre Dame. I actually started my career at Chrysler doing engine dyno testing, and that translated perfectly into joining Prolytics in 2019 to start doing smart plant P&ID, smart plant instrumentation type administration, data migrations, automation, all sorts of crazy stuff.
Okay. Yeah. And when you were in school, I imagine like the term P&ID was not something ever mentioned to you, right?
No. There's no
a lot of
equations
conveyors,
that have
gears,
P&ID. Yeah.
a lot of friction calculations on the turn, right?
That's right. Yeah.
A lot of blocks that are being pulled by a rope with a pulley and a certain coefficient of friction.
Yeah, cantilevered beams that have something hanging on the end and deflect.
Oh,
a
the
little
free
bit.
body diagrams
Yeah.
and stuff. Oh man, I like that. Okay. Well, so I was thinking, like, I always like to relate things in sort of an analogy, like what's the closest metaphor or comparison or whatever. And I was thinking about, like, in our industry, P&ID, piping and instrument diagram. So it's doesn't have dimensions. It's not trying to represent the exact sizes of like in to scale, right? You just indicate the size by text, right?
Yep.
And the distances aren't scale. Nothing's to scale. And so I was thinking about it, like, if you think of in the terms of like a book, to me, there's like your rough draft of a story would be kind of like what we're accustomed to in our industry is, like, to me, the PFD.
Yeah.
It's the simplest way to draw the chemical process of the facility at a high level. Like, get the big stuff right. What's the major equipment? What are the major lines? You leave some of the details out, and you have a process flow diagram, which is generally the basis that you use for a project. Now, you've had some exposure to where we're upgrading those from an old CAD package into a smarter CAD package, and we're trying to use them. But I don't know if you've seen, like, from a project perspective, have you seen their role or responsibility very much?
Not a whole lot. I understand at a high level what they're out there for, but yeah, I haven't actually developed a PFD on my own.
Okay. But does that kind of, like, rough draft analogy kind of make sense from what you see?
Yeah, it's like the zoom out on a map, right? If you zoom really far in, you'll see all the streets and side streets and things. You zoom out, you just see the major highways.
Yeah, exactly. Right. So that makes sense. And then if you're looking at a major project or a facility, like the full book, if you equate this to like a novel or something, the full book is going to be everything, all of the data sheets that are under that dictated the equipment, of this whole story behind every component, the whole connection of every component. So to me, that's not the P&ID, because the P&ID still stays at a level where I can represent some things with a simplex version, like one bubble might represent 10 things, and it just has a typical note, or, hey, it doesn't tell you all of the characteristics of something. It's just telling you that it exists, and you're going to have to dig deeper. So to me, if you've got the rough draft as the PFD, and you've got the whole data set as sort of the full book. To me, there's like a Cliff Notes version
Yeah.
of a book. Now, you're younger than me by at least 6 months or so. Um, are you? No, like 15 years. Are you familiar with Cliff Notes?
Yeah, I've used Cliff Notes before.
Okay, okay. Now it's actually, is it Cliff's Notes or just Cliff Notes? Do you know?
I think it is just Cliff Notes.
Okay,
I don't
just
know if there's a guy named Cliff. Maybe there is, and I'm doing him a disservice by
Okay.
saying this.
right, because it's supposed to be all of the stuff that you need to know, but it kind of glosses over some of the wordy stuff. And you're
Yeah.
like, you can figure that out later. Dig deeper if you want to. So does that feel like a good analogy to you to like what the P&ID is?
Yeah, I think that's fair.
Is that why we like it so much? Is that why it's such a big deal? Because it's like the just enough and not too much, I guess. Okay, so I don't know. I was trying to relate. So for those, I mean, because what we're hoping is that, people we work with, colleagues, other folks like watch this, they would already kind of know that. Maybe never thought about it that way though.
Yeah.
But then also maybe someone else is listening who isn't that familiar. But to me, that P&ID, piping and instrument diagram, is sort of like that Cliff Notes version of your facility. And we take the whole thing. Generally, you're talking a couple hundred drawings for a process unit or something at a facility. And so you kind of take the whole thing and you say, hey, in these 200 drawings, if I gave you just that tells you most of the story you need to know about what's happening here.
Yeah.
Okay. Okay, nice. Now, in your time previous to working in the energy business, when you're in the automotive business, is there any parallel to that?
I mean, it's similar. A car's just like a mini power plant, right? So we had, in doing engine testing and engine calibration, we would have like schematics of, the air induction system and the throttle, which is just a control valve for airflow. You've got temperature sensors in there, things like that. And we do have diagrams that show how those things are connected and what, series they are in. So you could have your temperature sensor upstream of the throttle and maybe an inlet pressure sensor and then a manifold air pressure sensor, and so you have to know in order to calibrate the engine where those things are located relative to each other. So we have some high-level diagrams that would show that related to the control system for your engine. Yeah.
Really? How many would you have for like a typical vehicle?
You could probably throw it up on one P&ID. It's not super complicated. I mean, you don't model the inside, so the engine would look kind of like a skid, I guess.
Like a black box piece of
once
equipment?
Once it goes past the inlet valves, yeah.
Okay.
But
Okay.
It's not as complicated, but it's still, I mean, it's similar.
Okay. Yeah, because in my project experience, the P&ID was like the backbone of the project. It was the thing that you knew you had to get right. It should be the authority. A lot of data goes there and then gets fulfilled or improved or grows as it goes out. But that's the first place you go to say, hey, look, we need more. We need another piece of equipment here. We need another piece line here. We need more instrumentation. So you mark it and then it would flow to the rest of the world there.
Yeah.
It's also kind of an interesting document in that it has piping, instrumentation, and electrical, and has process information, obviously, because the process is in the pipe. So like if you looked at a typical EPC, there'll be an instrument department. They have very clear deliverables that they have to generate for instrumentation, the data sheets for the equipment, the wiring diagrams and their control narratives and whatnot related to instrumentation. The electrical team is obviously speccing out the motors and the cabling and all that sort of stuff. But the P&ID itself, and so those deliverables were owned by that group or that department. And the P&ID though is a little confusing because it's a combination of all those, and in some places I've worked, it's actually kind of confusing to know, like, especially when we were trying to implement like a smart P&ID software, who is the person that gets to make that decision?
Yeah.
You know, because there wasn't a department for the document. It was shared. Sometimes the piping team felt ownership. Sometimes the process team felt ownership. And it was always a little bit of an interesting dynamic because for me, I started my career where all the P&IDs were AutoCAD basically, or MicroStation, but all of mine were AutoCAD. As an instrument and controls engineer, I would just receive the result of that. I had nothing to do with their creation, and I wanted to get stuff off of it. I wanted to get tags, and I wanted to get set points, and I wanted to get information off of it. So we were always looking for the best way to scrape that data or gather it. And then when the idea for me was introduced of, hey, there's this new option, which is a smart P&ID, which means it has a database behind it, I was really excited about that. But then trying to pinpoint who to go to influence and say, hey, we as a company really want to adopt this, it was a challenging idea because you didn't just have one person where you had to go convince.
Yeah.
You know, and so we could get like maybe the process engineering team was interested, but then the piping guys maybe, you know, they were more set in their ways with other workflows, didn't like the idea, and nobody had clear ownership to be able to say, boom, this is the way we're doing it, you know? All right. So the other thing I think that I like to think about too is that the P&ID itself is what's used then most commonly for the control system. So if you walk into a control room, you know, at an operating facility, you're going to go up to some graphical screens, and most of the time they're mimicking the P&IDs. And so they're an animated version of the P&IDs. And that was a cool experience for me to be on a project and then go out to the facility and see those drawings that we were marking up and we were improving the tags and the text and everything. And then you see them, they're up on the wall and they're turning colors, and you see when, you know, valves are opening and motors are running and all that sort of stuff. So, like, I think too, that's why that document is so important in the industry.
Yeah.
You know,
It's a great visualization of what's actually going on out there in the plant.
yeah, it's simple enough that you can use it for that canvas. You can use it as an engineering canvas where you study it and you're like, okay, do we think this is going to work? And then you can use it for an operations canvas. Hey, are we showing this the right way for an operator to be able to run this piece of equipment? Because if you look at like the 3D model, it's a prettier picture, right? I mean, it looks fantastic. It looks like a video game of the facility, and it's got all of the, just like you'd see on a map, like a 3D map, like you're in that world. You can see it, but it's too much information.
Yeah.
If you really want to study how it's operating or you want to improve it, you don't really need to know that. Sometimes you need to know that a pipe bends, or, you know, some of the physics and chemistry around that. But I mean, a lot of times you just, you know, that's noise in your decision-making process.
Yeah.
You know, so you look at that three-dimensional thing and it's just too complex to process. Now we're seeing that grow in popularity from like the digital twin perspective. People would prefer the 3D model, I think, is the canvas for a digital twin, because when you're thinking the digital twin, you're kind of thinking about studying the way that, you know, I'm looking for something, so I'll look for it in the context of how a human walks around the facility. I think that's really what we're seeing there. But for the canvas of your engineering project and your operations plan and everything like that, it seems like P&ID is the one.
Yep.
So
Yeah. I mean, like you said, everything's connected together in one source. So the control system's got a pressure sensor, and then hooks up to a pressure loop, and you've got a valve downstream. You could look at the loop diagram, but that wouldn't really show you, once you've moved that valve, you don't know where the flow is going after that. So the P&ID kind of connects it all together, so you can see what it's doing and what's upstream and downstream of that action that it's taking, right?
Yeah, yeah, 100%. There's nowhere like that diagram that you mentioned, that loop diagram. I mean, that's really like a wiring troubleshooting. So it doesn't tell you about how it's supposed to operate, how it, it does tell you that that transmitter is coupled with a valve of some type, and they're supposed to work together. But how, why, what is not in those documents.
Yep.
Okay, well then, so let's pivot a little bit there, from the concept of just P&IDs in general, why they're important, and talk a little bit about the concept of a smart P&ID. So you've had the ability, working on our team here, to work with that as a pretty heavy focus. I mean, in the industry, there are different definitions of smart P&ID. In general, I think that basically means a P&ID drawing that has a database behind it so that you can report out the work that's being done, the way the connections are done. When I first heard that term, I thought, well, just how smart is it? I mean, is it there to do the calculations for the process? Is it there to do other tasks that that other engineering or other disciplines would typically do in another format? And in my experience, no, that's really not the goal. I mean, you could, the idea of a smart P&ID, could it be leveraged for more advanced calculations and plugged in? Yes, it's possible. The fundamentals are there. But really, what we've done to this point is we've created a picture drawing with a map of all that information stored beneath it. And you've got some that are simple, some smart P&ID products where it's a relatively simple data set behind it, so you're just really getting more like a text dump of what's in there. And then and that some of them could even be connected to just like an access database or something like that. And then other more complicated softwares will have maybe like a full SQL data model beneath them, where you're talking about, a different hierarchy of object, and you have a table for all the equipment and a table for all the lines and a table for all the instruments, and then there's a relationship manager between those two guys, right?
Yep.
And so like you've had a lot of experience in analyzing that data and working with that. Like, have you, how was that experience for you, I guess, from working behind the scenes of those databases?
Yeah, I mean, it's really interesting. I think, you said what's the difference between the smart and the regular one? If you take an example of like trying to find all of your PSVs that are on a certain line size or something like that, the old school way would be to flip through page by page and look at them and try to find them. But, if it's all in a database, you can just write a SQL query that says, look up PSVs where pipe diameter is 6 inches or something, and it'll instantly give you a report of all those P&IDs, and you can add other properties in and things like that. So I think it's really powerful in terms of what you can get out of it. And then you mentioned relationships between items too, so you can, traverse those relationships and find out what's upstream and downstream of items, cool stuff like that, which unlocks power to do, all sorts of other stuff.
Yeah, I'm going to hit on that real quick, because whenever you're looking at a technology choice, software choice or a piece of equipment or whatever, you've always got to evaluate your ROI, your return on that investment, right? And the motivation. So in our industry, we're talking either project work or we're talking about maintaining an operating facility. So there are different drivers between why you use technology in those various instances. A project team is building a plan and trying to get it up to construction. So for them, they have a limited time frame. They have a volume of information they've got to provide so that it can be constructed on time, on budget, hit the shipping dates, get sent out and installed in its location wherever it needs to be. So there's an urgency there. Once you've got a facility, now you're talking about, okay, can we operate it safely? Can we manage the change on that facility? Can we manage projects over time? And can we leverage the data? And so I usually tell kind of the tale there is, from an EPC perspective, I want to use the tool like a smart P&ID. I want to use it to work fast by drawing something that I can then generate lists from. So if it was something I used to count, I want to be able to generate that. A piping line list, a valve list, a specialty item list. I want to be able to export that. And that way, in theory, I'm going to save time there.
Yep.
Also want to be able to integrate with other disciplines. So I want to be able to take the pieces, we mentioned process, piping, instrument, electrical are all involved in that document. So from an EPC perspective, you choose to use this smarter technology because you want to leverage, if you can get more data out of the P&IDs, I can make those other disciplines better by giving them a starting point on what they're doing. I can give them constant quality control back and forth, things like that.
Yeah.
So I often kind of describe the EPC mindset as mostly wanting to work faster and do more volume, right? And then from the owner-operator side, it's about consistency. So if I have a smart P&ID system, like the fundamentals of that are, I'm generally going to have some type of symbol library that governs what anything can look like. So if I'm editing the drawing, I've got to pull from my available symbology, right? And then I've got a data structure that says, okay, for this type of object, these are all the fields I have. And if I'm looking, like if I'm in the project side, I can define data sets and fields that'll help me do that integration I was talking about. But if I'm on the owner side, I now have a feed to connect into my asset management tools and my digital twin tools or whatever. And so the owner is typically then looking at consistency across that symbology and across that data set. Because in the old CAD methodology, you had more freedom to just freehand draw a new symbol or just add a new piece of text. There was really nothing restricting you from doing that, right? And so now when you're looking at, if I'm an owner-operator and I'm going to have 10 facilities and I'm going to standardize on a smart product, then I can standardize on my symbol library and my data structure. And in theory, I can have 10 facilities with 10,000 P&IDs, but they're all using the same symbols and they're all using the same data sets, and they can all export that data to the same places. And so we see a driver there to leverage it for that consistency, and then for if I'm going to do any changes to my plant, I have to work within that environment. As opposed to the older methodology of taking that CAD file, sending it out to somebody in a transmittal. They might add a new symbol. They might add a different way to notate something. When I get it back, if I had some scraping tools that were getting business value off of that, maybe those don't work on those new objects. Maybe I don't understand the visual because they use some different symbol, right? So you've done a lot of work with like owners that are managing thousands of P&IDs and multiple databases, right?
Yeah, that's right. A lot of our clients have, like you said, hundreds or thousands of P&IDs, and for them, they want them to be consistent, like you said. And if other people are coming in to do work in their plant, they want, their work to be pretty seamless with the work that their own drafters would be doing, and those smart libraries drive that home. So it's really helpful for them.
Yeah. Now the question comes, like, why would you not? Here we are, like the concept of an intelligent P&ID, was there in the 90s. Here it's 2026. Why would it not kind of just be the default for everything? It is kind of a default for greenfield energy projects. I mean, I don't think we've seen any new project work that we've been involved in where they weren't using some type of smart P&ID.
Right.
But there are some challenges in areas where it's, there's still a tendency to keep CAD. One of those that I can think of in particular is when you have a brownfield situation. So you have some facility that's already existing. They had drawings from the past. Maybe you're going to do a project and you're going to touch 10% of their facility. But does it make sense to redraw that 10% in a smart product when the other 90 is going to stay in CAD? And then when you're done with the project, what do you do with that 10%? Do you export it back to a CAD file and that's their life cycle tool? Or do you now keep, okay, well, we got 10% of the plant in this smart P&ID version and 90% in this CAD P&ID version? I've seen that dilemma quite a bit. Have you, run into that in any of your scenarios?
Yeah, I think so. I mean, like you said, it's a tough decision for them to make. It's a big investment to do that other 90% in the smart product. So you have to pretty much redraft everything, right?
Yeah, I mean, we do see some scenarios where someone makes a corporate decision that, hey, look, I'm gonna adopt this smart P&ID plan,
Yeah.
and I'm gonna go through and convert. And there are some partial auto conversion options, but you're talking about this is, as we said, the backbone of the facility. So getting it converted, it needs to be well checked.
Yep.
If you're gonna you're gonna convert it up to a different format, it needs to be well managed, and so there's obviously a cost involved in that, right?
Yeah, the cost plus, like you said, when you started out, you have to find someone to champion that too. I think if no one on the project team on the owner side wants to maintain that, and the EPC will hand it over, but there's no one to sort of steward that and champion it, it's gonna fall into, I don't know, just be unmaintained and eventually not really relevant anymore.
Yeah. I mean, I think there are some organizations we work with who have already made the decision that that's where they want to be. Therefore, if they get anything delivered to them from an engineering company in a smart format, they're going to keep it that way.
Yeah.
And maybe they're even doing conversions to actively, move toward like a full smart P&ID mentality. And then you've got others who really aren't well versed in the technology. Maybe all their facilities are operating facilities. They haven't had anything new in years. And then they might get a project, receive a project that is actually in smart P&IDs, and they don't know what to do with it. And sometimes they'll just save it out to, PDFs or CAD files or something, and kind of, unfortunately, that's like a real loss of value when that happens.
Yeah, it is. But I mean, those smart products are pretty complicated, and it's definitely harder to open that up and figure out what's going on than just open up CAD and see lines and text and be able to do what you want. So,
yeah, if you look at the personnel required, if you're literally talking about managing CAD files, IT can secure the licenses, get you the install file, and then there's plenty of designers out there that are comfortable enough with like an AutoCAD product or something like that where as long as they're getting a license provided to them, they're capable of stewarding those drawings pretty easily, right? But typically, like a smart P&ID product requires an administrator who's some sort of hybrid between IT and engineering. If you don't really have that culture in your company, it can be easy to be afraid of it and say, oh, well, we don't know how to manage that. Let's stay away from it, Okay. Another area where the drawings are not always going to be intelligent is on like your vendor drawings or something that's coming from a packaged equipment, somebody that already has basically a product packaged, they have a solution packaged in some sort of, bundle of data they give you, and you're an owner that maybe you're creating, the balance of plant around these different parts and pieces, but you got technology provided by a vendor, and you receive their drawings, then you have to make the decision, like, is that drawing set worth me converting into these other tools, or should I keep it natively the way that it was delivered to me? I think there's generally some question there about warranties and about what the expectations are, what type of equipment it is. But for us, when we see projects and the definitely vendor data is just an area, and that little situation extends to all the documents, to all the disciplines, because everything's coming to you in some format that's kind of off the shelf, you know?
Yeah. Yeah. I mean, it's like you said, warranty. Who's going to service it, right? If you're not actually going to service that piece of equipment, if you're going to call up the vendor and say, hey, come down and, fix this for me, then it doesn't add a lot of value for you to have that maybe in a smart format if they're the ones that are going to fix it and make updates to it. But if you receive it and then you own it and have to do all the maintenance on it, maybe in that case it makes a little bit more sense for you to start accounting for it a little bit better.
Mm-hmm. Yeah, I think so. Yeah, so those have been a couple of things. I mean, I've been involved with smart P&IDs for, I don't know, 15, maybe nearly 20 years. I've really enjoyed the capability. I've also kind of been through the progression as a user of where you look at this software and you're like, wow, there is just so much potential here. I've got the ability now to define this custom data set. If I really wanted to put in, an additional piece of information, I've got all the ability to define it. I can choose where I want to put it. Is that something that kind of goes globally across every object? Is that just a piece of data that applies to piping, or is it just a piece of data that applies to inline valves or to instrumentation? There's also in some of these packages, and I mean AutoCAD too. AutoCAD has some programming capabilities, but like I know, particularly in the smart P&ID world, you've often got this concept of like a data validation routine or a calculation that you can trigger anytime that something happens, So like, I think in general, it can be used as simplified as a drawing package with a data structure behind it. One that even in the simple forms, you can kind of throw away the graphic and you should have enough data from what's just the metadata of the drawing to actually recreate it all the connections and the origins and the coordinates and the symbology, and just regenerate it. So that's kind of cool. But you could go all the way from basically just using it to that. Or, I mean, if you wanted to, you could define 100 properties for every piece of equipment. You could store all of your equipment data sheet properties in the database. You could store all, I mean, if you wanted to.
Yeah.
I haven't seen anybody go that far, and I don't think that's the right idea, but it certainly is a tempting conversation around, like, oh man, what could we really do?
Yeah.
I always think about it like bring up the analogy, like, okay, if I was just going to do this with a project team of like 3 people, it was just the 3 best people I could find. Well, how creative would you get with the use of these type of packages, But when you look at a project team that's typically hundreds of people, usually spread out across multiple offices, generally a couple of organizations involved, I've seen most people dial back the innovation to just a little more than what you can see visually on the drawing. I mean, I think like a perfect example of that has to do with your line data. And so a traditional P&ID, I draw a piece of pipe, I tell it the size, the spec, what type of pipe characteristics I have, and then what's my fluid code, what's in it. And that's a bare minimum, is it or is it not insulated? That's basically what goes into a pipe that you draw onto a P&ID. But we know then, of course, from a process engineering perspective, there's a temperature of the fluid that's inside of that. That's not a physical that's not a property we have to worry about necessarily from constructability perspective, but there's the pressures involved, there's the flow rates involved, there's a lot of stuff around the process, and that's right where the industry starts to kind of bump their head a little bit on like how deep do we go with this?
Yeah, because you wouldn't show those on the P&ID, right? If you were looking at a printed out version, you wouldn't see the temperatures and pressures, even if it's in the database.
You
typically-
often wouldn't,
Yeah.
right? In rare cases, I've seen versions of the P&ID where maybe it was some type of optional display option where you could show that. In most cases, no. So yeah, you wouldn't show it, which makes it harder to review, right? So it's in there, but the typical drawing that's printed out, in the office where people can walk up and review it and mark on it, those values aren't there. So now you're storing additional information kind of behind the scenes.
Yeah.
And it becomes a real tricky challenge to understand how much of that you want to put in the tool. So I went through a phase where I was really ambitious from a project perspective and trying to push the envelope on that. And because I was interested in it and I had the access to the software more at an advanced level, which really isn't feasible, like across a big organization, to have sort of programmers be involved on the project. But I was kind of in a programmer type mindset and role, but on the job. So I was really passionate about how much data we could put in and how much we could get out. But unless we can find a workforce of available people to share that interest and to get management buy-in to share that interest, you can't really use the tool in that fashion. And so that's been my dilemma with it. Like, I know there's much more we could do, but projects are defining data engineer roles and stuff like that. Like, it's coming, but you really have to lean into that. And what happens is you start drawing stuff for the purposes, or entering it for the purposes of the extraction. And so you get into a little bit of a chase your tail type scenario where you're like, well, it's just that point of diminishing returns type scenario where you're like, I could do this, I could automate this. But with every automation idea comes some point where you're spending more time trying to do it cool, smart, than if you just kept it simple.
Yeah. Yep. Yeah, and at this point, if you've got another system of record that might hold that information, and you start putting it into P&ID as well, and you're duplicating it, and then you got to keep up with the synchronization of those two systems as well, which is kind of a pain. In modern times, it's easier to bring those together somewhere else and report them out in like Power BI or something, right? Rather than try and cram it all into SPID so that it'll show up in your SPID line list report, and also have it like somewhere else in ABE or some other engineering data source, Excel file, access database for your line list.
Yeah,
Depends on what you're doing.
I think in general what we're seeing is, number one, just because you can doesn't mean you should.
Yeah.
Right? So like SPID can be the product you mentioned, Hexagon Smart P&ID, it can be customized to a really high degree. Even so, like, you can validate every click that somebody makes, and you can check that that answer that they typed in was something you agree with or disagree, and you could flash a message up. You could tell them to do a whole bunch of things. You could put a whole bunch of properties in there that aren't shown, but you use them to report.
Yep.
But typically, like, what we're seeing is, because these tools like that are life cycle tools, they're going to go from the original organization through some sort of other phases and eventually to the final resting place, maybe even transition from one owner to the next if a facility gets sold.
Yeah.
And there's value in keeping those complex products implemented in a rather simplistic way. so that they can be upgraded, they can deal through the years with operating system changes and all that sort of stuff. And so the the automation possibilities are hard to realize, you know. So I know you've dabbled in some of the programming aspects there, but you're kind of always hoping that whoever you're writing that for has someone who's just as passionate about how they're going to use it,
Right.
right? Because like a lot of times when people think about automation, you think, well, I'm going to take a task that we used to have to do manually, I'm going to automate it, and then people can forget about it. And like, you don't actually want them to forget about it.
Right.
You want them to know how it happens, why it happens, and then watch to make sure that it is happening. Yeah, they can not do the grunt work anymore, but they can't forget why it's there, I think. Does that make sense?
Yeah, it does for sure. I mean, someone's still got to check all the data that gets entered into your drawings, right? No matter who gets it there, whether the drafter types it in or it gets calculated in the background based on other inputs, you still have to stand by what's in your database and on your drawings.
Yeah, even if it's a calculation that you're doing or whatever, you just want to understand the fundamentals of it, and you want to, you know. So, I mean, I think these products are interesting. I certainly have interest in the conversation around the intelligent P&IDs and around how that could be leveraged. But every time I know that we're not pushing it to the limits,
Yeah.
because those limits just may not fit with where people realistically are going to manage it, and that may change over time. Now, the last thing I'll mention is the this idea about the ROI. You know, primarily the long-term usage of these tools is in the lifecycle management for the operator, and the conversation around, is it worth the effort to do this in the administration, to use a smarter product rather than a CAD product? Is it worth it just for what I mentioned earlier, just for consistency or just for a simpler management philosophy? And a lot of times the answer has kind of been, not really. Like a lot of people come to that decision. I mean, I don't necessarily agree with that, but I'm saying that like I've heard that decision quite a bit. But I think there is something that's changing with that, which is this graph database concept. And you touched on it earlier, like the relationships between objects.
Yeah.
But I'm seeing people justify now the smart P&IDs because if I can take that drawing and use that data to create a graph database, and I mean, you have some more knowledge there, like from a graph perspective. Can you tell me a little bit about that?
Yeah. So, I mean, just in the most basic terms, a graph database is really just a bunch of items, which you would call nodes, and then the relationships between those items, edges. So in the case of a P&ID, it'd be like the nodes would be equipment and valves and things, and the edges would be the relationships between those. So pipes that connect them and flow direction on those pipes. And so if you have your plant's data in this graph format, which is kind of like what a P&ID sort of is already, because you've got your objects and the connections between them, you can write queries against the graph database to tell you, where do I have a pump where I, have this type of valve upstream of the pump, and it could quickly query that for you based on relationships, not just based on a list of properties. I think the difference between graph databases and just traditional tables is that you're really going across relationships between items rather than just properties inside of, a list of the items.
Well, if you think about a typical, like, what's the default, like a Northwind database that Access used to throw one out. That was like your default database, and you had a chart of, like, you had a table of people, and they had a location or something, right? So the connector between location and people was some type of key. It was a location ID of the person. And what you're saying is, like, in the P&ID equivalent, if I've got equipment and a pump, Well, the connector between those two, the ID that connects those two, is whatever pipe connects that equipment and that pump, I guess, right? And so you've got a
Yeah.
little node that is the equipment, and it has a connector to a piece of pipe, which has a connector to a pump. And then what you're able to do is you're able to, because even the P&ID, it's laid out because of the complexity of the interconnections or whatever. You know, you have a line that'll come out of the top of something, and it'll have to jog around a couple of things to get to the side of the paper, and then it'll say, hey, I have an off-page connector, and I'm going to go to some other page. And so it can be hard to follow the relationships because a drafter was trying to fit it onto a sheet of paper, right? And I guess in a graph perspective, you're able to say, hey, I don't care about any of that. That was just a drawing choice that someone made for clarity. I just want to see objects and connectors in like a web, right? So you basically take what we already said was like a Cliff Notes version, and now you create even like an outline, like a simpler view of that version where you cut all the crap. You don't care about the formatting. Almost like, too, you could drag a node around or whatever so you can understand the connections in the flow. Is that right?
Yeah, it could be connections in flow or other types of relationships too. But yeah, it kind of distills down the P&ID based on what you're searching for just to those specific relationships between items.
Okay. Yeah, and we've got there's a lot of technology now about reading older P&IDs, legacy P&IDs, and trying to create the same equivalent in sort of a graph database. The problem there is you don't natively have as much data available in that picture, so the AI technology or whatever that's trying to process those can do okay. But if you have a data set that's got a picture plus it has a full data model behind it, you inherently have a head start on creation of that graph.
Right.
Is that right?
Yeah, you don't have to have any sort of AI model that's trying to interpret the symbology to make those connections between objects and tell what type of connection they are. If you've got it in a smart P&ID, then those connections should already be made if they've been drafted correctly, and you can just query the database to figure out where they exist and then translate that into a graph.
Yeah, and we're seeing people be able to justify, hey, I really should invest more in a smart P&ID because the graph database gives me potential power for things like studying my equipment isolations, studying its circuits for the plant and stuff like that, right?
Yeah, has ops, things like that.
Okay. Well, I lied because I have one more point, Danielle, before we're done. I know we're running long, but well, what I was going to say is, too, so the P&IDs currently, I mentioned earlier, like a couple hundred for a facility, but that's actually not true. That's because we had to start on a piece of paper, and a piece of paper was a certain size, so we fit everything we could on a piece of paper. And then when we transitioned over into CAD or even into a smart tool, we still kept the paper. But the truth is, the P&ID is really just one map, just one model of the facility. And I think we're going to move to a point in the near future where we get rid of the paper concept and we just look at it like the same way. If I go to a 3D model, I can zoom out and I can see the whole facility. So I'm seeing it in one view. And then I can zoom all the way into something and I can see just a little bit. I think from a P&ID perspective, because what we're going to do is we're going to create these graph databases, and they don't care about paper anymore. So you're going to look at it, and you're going to say, oh, look, I can see the whole facility in a graph. And then you're going to look back at the piece of paper, and you're going to be like, why was I ever doing that in the first place? Why don't I just draw it like this? I still need to translate it into like nodes and whatnot for like my other analysis. But even my normal drawing, why don't I just look at a facility on the wall? You know, there's a little technology involved, right? Like monitor size or processing speed or all that sort of stuff.
Right.
But I mean, we have, like I mentioned earlier, off-page connectors, a whole bunch of little, basically fake connectors between one page to the other. to show you that something is connected, I've got to think we're going to be moving to a point here in the near future where the paper size is not the limiting factor around how we break up a facility. You know what I mean?
Yeah. Yeah, I mean, it's interesting to think about, but it's another one of those things that how are you going to get the old guys at the plant to adopt that? You know, they're so used to breaking things down into that, nice sheet of paper.
Well,
they're going to have a whole new navigation system, right? Other
yeah.
than just flipping through.
And we've gotten real accustomed to our smartphone where you look at something, you squeeze it, zoom in, squeeze out, zoom out. I mean, I think we're just going to be looking at a situation where you just walk up to the wall, and you want to look at a piece of equipment, you just zoom in on it and then you zoom back out. But we're going to be making our decisions irrespective of 11 by 17 imaginary boundaries that don't mean anything.
Yep.
Because we're already doing projects where the whole project's online anyway. You're not really printing anything. I mean, in the old days, we had what was called a stick file because it had a actual stick that like stuck all the paper together. So you had this giant, and you could hang it on a drafting area. So you had the P&IDs were on a stick. And it was the master stick file, they called it, right? And so, yeah, you had to have something that you could carry over to the table, lay on the table, mark it up, and then put it back in the pile. But, I mean, I think those days are done. So I just think what's going to happen is we're going to kind of like reverse convince ourselves through the graph that that's a more friendly way to view the facility anyway, and why can't we just get rid of these imaginary borders?
Yeah.
So... Okay, fantastic. Well, I think that's that's part one of like 100-part series we're going to do on P&IDs.
Sounds good.
Yeah. All right. Well, cool. Thanks, Ted, for joining us, and thank you guys for listening.
Yep. Thanks, Mike.